Okay, so we're going to prove this theorem using the three axioms of probability. So just to go over briefly what the three axioms of probability are, the probability of any event in the sample space is always bigger than or equal to 0. The probability of the entire sample space is equal to 1. And for any number of mutually exclusive events, a sub 1, a sub 2, a sub 3, and so on, the probability of their union is equal to the probability of each of them individually. So the probability of a sub 1 union a sub 2 union a sub 3 and so on is equal to the probability of a sub 1 plus the probability of a sub 2 plus the probability of a sub 3 and etc. Right? Okay. So here we have this theorem if a sub 1 is a subset of a sub 2. So let's go ahead and draw that picture, right? Oh, let me do a better job. Let's see. So here's our sample space. So here is a sub 2, and here is a sub 1. So if a sub 1 is a subset of a sub 2, then the probability of a sub 1 is less than the probability of a sub 2. Well, naturally, right? The probability of a sub 2 is bigger than a sub 1. And the probability of a sub 2 minus a sub 1 is equal to the probability of a sub 2 minus the probability of a sub 1. So remember from set theory, a sub 2 minus a sub 1 is all of the elements in a sub 2 and not in a sub 1. So that would be all the elements in a sub 2 and not in a sub 1. So this shaded region would be a sub 2 minus a sub 1. Well, clearly, we can see that a sub 2 minus a sub 1 is equal to the probability of a sub 2, which would be this whole thing, right? Minus this little piece here, so that would give us that same area. So at least intuitively, we can see that this is true. And remember, mutually exclusive events just means that none of these events share outcomes, right? Or none of them share elements, right? Their intersections are all the empty set. All right, so now let's go ahead and start this theorem. Okay, so proof. We're going to assume that a sub 1 is a subset of a sub 2. Well, if a sub 1 is a subset of a sub 2, what I know, this implies, right, that a sub 2 is equal to a sub 1 union a sub 2 minus a sub 1. Now, look at this. Since I know that a sub 1 is a subset of a sub 2, I know that a sub 2 is equal to a sub 1, which would be this piece, union a sub 2 minus a sub 1, which is the shaded piece, right? So we can see that from the picture. And notice that I created two mutually exclusive events, right? A sub 1 is this unshadowed piece here, and a sub 2 minus a sub 1 is this shaded region here. So I know that a sub 1 intersection a sub 2 minus a sub 1 is equal to the empty set, aka these two sets are mutually exclusive. So I can actually use one of the axioms. But first, since I know that a sub 2 is equal to this means that the probability of a sub 2 is equal to the probability of a sub 1 union a sub 2 minus a sub 1. And now, since I know that a sub 1 and a sub 2 minus a sub 1 are mutually exclusive by, what was that axiom? By axiom 3, I know that I can just separate them. The probability of their union is just the probability of that set plus the other set. So by axiom 3, I know this is the same thing as probability of a sub 1 plus probability of a sub 2 minus a sub 1. So now I have this equation right here. I have the probability of a sub 2 is equal to the probability of a sub 1 plus the probability of a sub 2 minus a sub 1. All right, well, In my theorem, I wanted to prove that the probability of a sub 2 minus a sub 1 is equal to the probability of a sub 2 minus the probability of a sub 1. And that's what I have right here. If I just subtract the probability of a sub 1 from both sides, I would get that the probability of a sub 2 minus the probability of a sub 1 is equal to the probability of a sub 2 minus a sub 1. Or I can rewrite it like I have it in the theorem. The probability of a sub 2 minus a sub 1 is equal to the probability of a sub 2 minus the probability of a sub 1. And that's part of the theorem that we are looking for. Now we're looking for to prove that the probability of a sub 1 is less than or equal to the probability of a sub 2. Well, according to our first axiom, I know the probability of any event in the sample space is bigger than or equal to 0. So, by axiom 1, I know that the probability of any event, so a sub 2 minus a sub 1, is bigger than or equal to 0, right? Well, I know that the probability of a sub 2 minus a sub 1 is equal to this, right? So this implies that the probability of a sub 2 minus the probability of a sub 1 is bigger than or equal to 0. If I add the probability of a sub 1 to both sides, this gives me that the probability of a sub 2 is bigger than or equal to the probability of a sub 1, which is exactly what I wanted to show. I want to show the probability of a sub 2 is bigger than the probability of a sub 1. Of course, I can rewrite it exactly like in the theorem. Or the probability of a sub 1 is less than or equal to the probability of a sub 2. And that is our first theorem for our probability.